Hello, class. So, okay, let's begin with the resolution to the problems. To those problems from these exercises from the second chapter that you found either completely unintelligible or very hard. I was taking a look at them and I was surprised that I found some problems that are actually quite simple, guys. For example, in this case, in this exercise, a lot of you selected this one. This is actually quite simple. Maybe you only didn't understand like a specific part, which I gather should be this one, the equation. But the other stuff is quite simple. But anyway, that's just my opinion. Okay, so I'm gonna be solving like I told you, maybe a couple of them from each section. Okay, maybe sometimes three, maybe just sometimes one, but on average, a couple of them. The ones that you should selected as the most difficult. I'm gonna be making pauses in between, and I will probably give you these solutions in either two or three parts, like two or three videos. So let's begin. From section or from exercise 2A, you selected this one as the most difficult. And this one says the following. For each of the relation types below, give an example that is not a function. So let's address that already. Okay, so a table of values. How can I draw a table of values that is not a function, that doesn't represent a function? Quite simple. All you have to do is this. Well, you can do it either horizontally or vertical. It doesn't make any difference, right? Okay, so in this case, we can write something like this. I'm making things up, right? I don't have anything prepared. And by the way, I need you, I need you to notice that I'm gonna be, let's say, facing these problems. I'm gonna be trying to solve them without anything really rehearsed. You see, so all you're gonna see from me is what I think in real time. So 1 comma 2, 2 comma 3, 2 comma 4, and I can stop right there. Okay, and I can put these same values in a vertical way. 1 comma 2, 2 comma 3, 2 comma 4. Okay, so this is a table of values. Either they're just in different positions in which you don't have a function, right? Because if we select x as the independent variable or the input, and if we select y as the output, then for these particular two columns, 2 comma 3 and 2 comma 4, basically what we have is that for the same input, which is 2, we have two possibilities for the output, right? And that, as we know by now, that actually breaks or violates the definition of function, that for each input we should only have one output, and this is the same, right? So that takes care of letter A. As a mapping diagram, okay, actually I'm gonna play with this idea as well. So if I draw these two sets, the set of the inputs, the set of the outputs, all my inputs live in here as dots, all my outputs live in here as dots, and maybe this is gonna happen. One goes into two, one is mapped into two, and that reflects this part here. And then two maps into three, but also two maps into four. So maybe this is the number two, and it's being mapped into the number 3 but also into the number 4. That's it. This is the mapping representing this table of values, and that's it. As an equation, well, I cannot uh, continue using this idea with an equation, but an equation. An equation, for example, like this, guys. This is not a function. Not a function. Why not? Why not? Because of this. If you think of this equation and all the pairs of numbers x comma y that satisfy this equation, and what do I mean by that? I mean the following. For example, if you consider the pair 1 comma 0, 1 being the x, y being the 1 being the x, 0 being the y, then you can see that this pair of numbers satisfies this equation. What does that mean? That when you input this value, which is the x, into the x, and when you input this number into the y, then you can clearly see that 1 to the square plus 0 to the square is equal to 1. So this satisfies this equation. All right. Okay. The problem is this, guys. The problem is this. Take a look at this. I want you to take a look at this. 1 comma 0 satisfies, 0 comma 1 satisfies, um, 0 comma minus 1 satisfies, and minus 1 comma 0 satisfies. You can check all of this. All of these pairs satisfy this equation, because in the end, the fact that these numbers are negative, these two ones are negative, make no difference. Make no difference, because in the end, you're gonna elevate those numbers to the square, you see? And so this is my point. Why is this equation not a function? Why is it not a function? Because if you observe these ones, take a look at these guys. Take a look at these at these 2 points. For the same x of 0, and remember, once again, we usually consider the x as the input variable, okay? Unless something else is stated, we understand the x as the input variable. Okay, so for the same x, for the same input, we get two different outputs. We get 1 and minus 1, you see? Therefore, that's what makes this equation not a function, because the points that satisfy this equation are violating the definition of function, which is that for one input we should get only one output. These 2 points in particular are violating this very fact. And as a graph, actually, let me draw the graph for this one. If you go to Desmos and graph, go to Desmos and graph this thing, you're gonna find that this is the graph. This is the Cartesian plane, and the graph will be a circle, a circumference with radius 1. So it's gonna cut at 1, minus 1 in here, 1 in here, and minus 1 in here. Okay, this is the graph for this equation. And as we know by now, when you have a graph in the Cartesian plane and you run the vertical line test, let's run it. There you go. I only need one, in fact. I don't need two or any more. And if I draw a vertical line and that vertical line cuts the graph at more than 1 point, then what I have in here is not a function. Not a function. So that takes care of this problem number 2. Okay, so we're gonna be doing this in this way. I'm just gonna be solving these problems. No rehearse. I don't have anything prepared. I'm facing them kind of like it's the first time, and I'm gonna be making pauses in between. So we continue with exercise 2b. In this section, you clicked on problem 4 and problem 5. So let's see problem 4. It says to convert the temperature from Celsius to Fahrenheit, we use the formula, this one, F of C equals 9/5 times C plus 32. Is this formula a function? Justify your answer. Okay, so is this formula a function? The answer is yes, guys. Yes. Let me write down the formula. Remember, how do you pronounce this? F of c equals 9/5 c plus 32. You must understand what this formula does, or what this equation does. What this equation does is basically um, it converts. It converts. Okay, it's a converter from Celsius to Fahrenheit. Okay, so basically, if you wanna understand this equation as always as a machine, right? This this function is known as f, capital F. You're gonna input uh, an input C, which is a certain number of Celsius degrees, and this is gonna give you a certain number of Fahrenheit degrees Fahrenheit. This is what this function does. This is what this equation interpreted as a function does. And why do I claim that this is a function? Because for a certain value of Celsius degrees, guys, I don't know, let's say 25 degrees Celsius room temperature, this can only have one conversion into Fahrenheit, like so many degrees Fahrenheit. We don't know how many at this moment, but we know that it's just a specific value, right? When have you ever heard of a specific temperature in Celsius being converted into two possible Fahrenheit degrees? That's just impossible, right? It's impossible. So that's why you should understand that this equation, okay, this formula, this machine is in fact a function. Why? Because for each input you get only one output, and there is no way around this. B. Describe what f of 17 is, asking, and calculate the value. So letter B, when we write this symbol f of 17, what is this telling me? Like, what is the interpretation? Okay, well, if you understood what I told you here, like this function being a machine, you input a certain number of Celsius degrees, and this will convert this input into the corresponding Fahrenheit degrees. Then what this symbol means is obviously like how many degrees Fahrenheit correspond to 17 degrees Celsius, right? Basically, it's this. It's basically trying to attempt the transformation of 7 degrees Celsius into its corresponding degrees Fahrenheit. That's what this means. That's what this means. And of course, the proper answer, I'm going to continue over here. It's just the evaluation of 17 into this equation. So that's going to be 9/5 times 17 plus 32. And that's it, guys. That's all you have to do. Okay, then you carry out this arithmetic. I'm not going to do it for you. Um, that's it. That's it. Whatever number appears in here, that's going to be the number of Fahrenheit degrees that are equal to 17 degrees Celsius. Done. That's it. Letter C, describe what f of c equals 100 is asking and calculate the value of c. Well, this is the inverse problem, right? If I write this symbol f of c equals 100, what I'm asking is this: what is the number of degrees Celsius that correspond to 100 degrees Fahrenheit? You see, that's it basically. So if you want to see a diagram, imagine that we input a certain number c of degrees Celsius into this machine, this converter, and what you get as a result is 100, right? You're asking for this number. what was this number basically that gave me 100 Fahrenheit in the end. Okay, so what do? We take the formula, right? And if you're told that f of c equals 100, then make that substitution in here. F of c is equal to 100, right? And as you can see here, this is an equation with only c as a variable, and you need to solve for c, period. I'm not gonna do it for you. This is basic algebra, and I'm not gonna be doing these things for you. D, use the formula to calculate the temperature in degrees Fahrenheit at which water freezes. Okay, that just involves a little research online. Like you have to write on Google at what temperature does water freeze, and you're gonna get that water freezes at 0 degrees Celsius. And that's it, guys. Just use this formula once again to check at how many degrees Fahrenheit water freezes, right? So basically just input the number 0 in here to get the corresponding value of Fahrenheit that corresponds to 0 degrees Celsius. It's going to be 9/5 times 0 plus 32, which is 32. 32 degrees Fahrenheit correspond to 0 degrees Celsius. Done. E. Use the formula to calculate the temperature in degrees Fahrenheit at which water boils. Pretty much the same as D, but now water boils at 100 degrees Celsius. I'm not gonna do the rest, it's on you. F. The average body temperature of a dog is this many Celsius degrees. Convert these degrees to Fahrenheit. This is pretty much the same, guys. You see what I mean? Like, mm, just convert these to Fahrenheit. That's basically, you don't really care about the context. You see, I don't. The fact that this is talking about the body temperature of a dog and so on makes no difference. All you need to do here is convert these many Celsius degrees into Fahrenheit degrees by using this equation. That's it. Cookies are typically baked at, yeah, pretty much the same stuff. It's the same stuff. We don't have to go deeper into F and G. You can do them on your own. Okay, let me make a little pause and I'll come back with you. Okay, problem number 5, same section 2B. Problem number 5. We have a company of internet, right? And they offer a roaming data package to customers, a flat fee of 25 pounds. I think this is the one for pounds, right? I hope I'm not making a big mistake. Plus 10 pounds per gigabyte of data. All right. So letter A, express the total cost. C. What this C means is total cost as a function of the number of gigabytes of data used, represented by G. Total cost, C. Number of gigabytes of data used, G. All right. So what is a flat fee? A flat fee is the stuff that they charge basically for just having the service, right? It's kind of like um, I don't know how to tarifa. I don't know. I don't know how to. I don't know how to translate this into Spanish. Tarifa fija, maybe. I guess that's the translation. So basically, you're gonna pay for this 25 pounds, even if you don't use any gigabyte of data. That's what I mean. Okay. Okay. So let's see. Express the total cost as a function of the number of gigabytes of data. So we have this variable cost, and gigabytes of data used, number of gigabytes of data used. This is a function of this. So you know already that we should have in the end something like this. This variable is equal to a function of this other variable. This is the input, this is the output. Okay, okay, very good. So how do we calculate this? It's done in this way. The total cost is equal to the number of gigabytes of data times 10 pounds plus 25 pounds. That's it, guys. This is it. This is it. The cost that you're going to be paying is equal to 10 times the number of gigabytes you use plus the flat fee of 25, right? I think you should understand this just by looking at it. Just by looking at it. Now, how can I put this into functional notation? If I'm telling you that the cost is a function of g, then basically just make this substitution, right? F of g equals 10g plus 25. That's it. This thing and this thing are telling you exactly the same, because I'm telling you that c is, or c equals, a function of g. C and f of g both represent the same. It's the output. This is the output, and this is also the output for this particular input of the number of gigabytes of data. So this is the answer to the first question. B, what values of g do not make sense in this context? Any negative value, right? Negative values of g, because one cannot make use of, I don't know, minus 5 gigabytes of data. What would that possibly mean, right? What would something like this mean? Minus 5. I have used minus 5 gigabytes of data in downloading a certain file or something. This makes no sense. So what values of g do not make sense? Negative values. Negative values. C, state the notation that could be used to find the roaming cost for a trip where 14 gigabytes of data is used. Calculate this value. Okay. State the notation that could be used to find the roaming cost. Okay, we're looking for a cost, and we know that we used 14 gigabytes of data. Then what you are looking for is this, f of 14, right? This is what you're looking for, f of 14. You see the value of the function, which is the cost when you have used 14 gigabytes of data. And if you know that f of g is equal to this, then all you need to do is a simple substitution. F of 14 equals 10 times 14 plus 25. Calculate this thing, and that's going to be your answer. State the notation that could be used to find the number of gigabytes of data one can use for a total bill of 100 pounds. It's the same problem, but in reverse now. Okay, now we know that if we use a certain number of gigabytes of data, we're gonna be charged 100 pounds, right? So basically, all of this equation is asking uh, find the number of gigabytes of data so that your bill comes at 100 pounds, right? And the same as before, write down your function and make the substitution, right? F of g equals 100, so all of this is going to be 100 equals 10g plus 25, and then solve this equation for g, and you're done. I'm not going to be doing this for you now. Maybe some other of you guys, or let me clean this bit. So what if somebody of you wrote, instead of f of g equals 10g plus 25, what if somebody wrote this? C of g equals 10g plus 25. Is this correct? Of course, this is correct. Then the name you give to the function, guys, makes no difference. In here, I called it f because it's customary. But if you want to call it c, the same as the output variable, which is the cost, well, it was stated over here. It's okay. Just you need to understand that this is the name of the function. This is the name of the function, and you don't um, you need to be aware not to confuse the name of the function itself, okay, with the name of the input variable, which in this case is g. This is the input variable, and the name of the output variable, which is c. In order to make the distinction between the name of the function and the name of the output variable, it's often customary to write the name of the function in capital letters and this one in small, in what do we call this? Lowercase. Lowercase. This is the output variable. Output variable, right? So the output variable is a function of the input variable through this function, the function cost. This function, let me do it here. This function can be interpreted as a machine, capital C, right? This is a machine in which you input the number of gigabytes used, that's the input variable, and this function will give you the cost, lowercase. If you want to use also the letter C to represent the function, then you have to make a distinction between this name and this name. This is the name of the function, this is the name of the output variable. You cannot have the same variable, like in the same type, la misma tipografía. Like you cannot do this. This would be incorrect. And I know this is very technical, and this confused me a lot when I was in high school and the first semesters of college. You're gonna get used to this, all right? You're gonna get used to these ideas in due time. Just give it time. Just give it time. So that finishes the problem number 5. A small pause and I come back. Okay, exercise 2C, problem number 2 and number 3. Those were the ones that were selected. So given this function f of x equals x squared plus 1 and g of x equals minus 3x plus 2 and h of x equals the square root of x, use your calculator, graphical display calculator, to sketch the graphs of the following. A, B, C, and D. Okay, I'm just gonna show you one of these guys. If you understand one, you can pretty much do the others. Okay, so we have these functions f, g, and h, and basically what they're asking you here is to do some algebra of functions, right? What is f of x? Is this, according to this equation, right? F of x equals x squared plus 1, right? So when you read something like this, you should understand that you should add the values of f of x and the value of g of x, right? So once again, f of x is this much, substitute, that's it, right? F of x is equal to this, plus the value of g of x, which is minus 3x plus 2. Okay, so all of this is equal to all of this. And then simplify, if possible. In this case, we would have x squared minus 3x plus 3. That's it. That's it. So what is my conclusion? My conclusion is this, guys. F of x plus g of x equals x squared minus 3x plus 3. That's it. This is what we know as a sum of functions, which is itself a function, right? When you add two functions, guys, like in here, you get another function in return. And this function may be called by a different name, right? We may call this function, I don't know, s of x, which is equal to this. I'm sorry, x squared minus 3x plus 3. And what is s of x? It is the sum of f of x plus g of x. You can use any other name for this function, right? And then you have to sketch. You have to sketch this function. All you have to do is go to Desmos and just put these guys, put that in there. Let's go to Desmos. Just write s of x or any other. I repeat, guys, any other name for the function works. It doesn't have to be s. X squared minus 3x plus 3, if I remember well. Was that the one? X squared minus 3x, x squared minus 3x plus 3. Okay, so that's it. This is not a sketch. Once again, this is actually the graph of the function. And what we understand by sketch, what we understand by this word sketch, is basically what a human would do to grab this function quickly. Okay, you don't have to be too technical or too precise or anything. All you have to do when you do a sketch of a function is something very close to this. This is the technically this is the precise graph of the function, and the sketch would be, I'm gonna do it in here. Uh, you're gonna have to draw the axis, right? Not too well, like you don't need a ruler or anything, and just sketch the following. You're gonna sketch a parabola that opens upwards, like it goes in this direction and not in this direction. This is opening upward, this is opening downwards. That is the difference between these two types of parabolas. And basically, guys, just draw it crossing this point, which is 0, 3. So you have to make only this, like highlight this point, make the parabola go through that point, kind of like this, and just write the coordinates of that point of the intersection with the y-axis. This has no intersection with the x-axis, and pretty much, this is it, guys. Pretty much, it's just the general behavior of this function. By looking at this sketch, one understands that the function is parabolic, that the function crosses the y-axis at the value of 3, that the parabola opens upwards, and that it has this location in relation to the y and the x-axis, right? The vertex is in the first quadrant. That's it. It's just a very rough idea of how the actual graph behaves. This is the sketch, this is the technical graph, or this is the precise graph of this function. And you have to do the same for the rest. Okay, that's it, guys. That's all you have to do. And problem number 3, um, well, it's pretty much the same. All you have to do is just use Desmos to graph these things, to make the drawing. What we understand by drawing the graph is this, guys. This is the draw of the graph, and the other is the sketch. So that is the difference between drawing. This is the drawing, and the sketch is the stuff that I did in here. We have to make that distinction in the IB between the word sketch and the word draw. They are different. Draw is precise, sketch is so-so. Okay, that's it. Nothing else to add. Okay, I think I'm gonna stop it right here, guys. I'm gonna continue later on a different video.